Hello everyone. Today we will go for further few more problems on losses of pre-stress. So today's first problem, a concrete beam is pre-stressed by a cable carrying an initial pre-stressing force of 300 kN. The cross-sectional area of the wires in the cable is 300 mm square. Calculate the loss of pre-stress in the cable due to shrinkage of concrete using IS 1343 recommendation, assuming the beam to be pre-tensioned, post-tensioned. Assume ES, that is Young's modulus of steel, 210 kN per mm square and age of concrete at transfer 8 days. So in this problem, the initial pre-stressing force is given and the cross section of wires is given. You need to find out percentage of loss by considering loss due to only shrinkage of concrete. So by assuming if the beam is pre-tension, what is the loss due to shrinkage, and what if it is post-tension, what is the loss due to shrinkage. So first let us go for pre-tension member. Loss of pre-stress due to shrinkage in pre-tensioned member. So by using IS 1343 code book, you can get the shrinkage strain value for pre-tension member, that is 0.0003. So loss due to shrinkage is shrinkage strain into Young's modulus of steel. So that by substituting we will get 63 Newton per mm square. Percentage, here 63 Newton per mm square, it is the stress, but pre-tensioning force is given, so you need to calculate first stress, that is load by area. Force is 300 kilonewton upon area of cross section is 300 mm square. You need to get that, so it will become 1000 Newton per mm square. So for that you need to find out percentage. Similarly, loss due to pre-stress, loss of pre-stress due to shrinkage in post-tension member. Again by using IS 1343 code book, shrinkage strain is given by 0.0002 upon log of T plus 2 by 10 to the base 10. So T it is given 8 days for transfer. Substitute 8 in place of T, you will get shrinkage strain of as 0.0002. Then again substitute in shrinkage strain, find out, you will get 42 Newton per mm square again, and percentage of loss. Next problem, a concrete beam is post-tensioned by a cable carrying an initial stress of 1000 Newton per mm square. The slip at the jacking end is 5 mm. The modulus of elasticity of steel is 210 kilonewton per mm square. Estimate the percentage loss of stress due to anchorage slip if the length of the beam is 10 meter and if it is 5 meter. So that is delta is given, anchorage slip it is 5 mm. Young's modulus of steel is given. So loss of pre-stress due to anchorage slip in a beam of length 10 meter. So we know formula, loss of pre-stress due to anchorage slip is Young's modulus of steel into anchorage slip upon length, total length of the beam. So ES is given, delta is given, and L is given. So this formula is available in code book. You can substitute and get the value. Similarly, if it is 50 meter length, substitute length as 50 meter and calculate the loss along with percentage loss of pre-stress. Next problem, a pre-stressed concrete girder of 40 meter span is pre-stressed by a parabolic cable concentric at supports and having an eccentricity of 100 mm at the center of the span. The initial stress in the wires is 1200 Newton per mm square. Ultimate shrinkage strain is 0.0002 Young's modulus of steel is 210 kilonewton per mm square. Anchorage slip is 8 mm. Estimate the percentage loss of pre-stress. See, in this question, you need to analyze what are the data given first. So, span is given, okay. Then it is parabolic profile, okay. Then eccentricity is 100 mm. Then initial stress in wires, it is 1200 Newton per mm square. Ultimate shrinkage strain is 0.0002. Young's modulus is given. Anchorage slip is given. If you see the formulas of different losses and the question, by data given you can decide. You need to find out loss due to shrinkage and loss due to anchorage slip. If you want to calculate elastic shortening, you need cross-sectional area of the beam. It is not given. If you want to calculate friction, you need friction coefficient and wave coefficient. It is also not given. Then relaxation, still we have not yet reached it. So like that you need to see the question. So in this question we have two losses. One is loss due to shrinkage of concrete, shrinkage strain into Young's modulus of steel. It is 42 Newton per mm square. Then loss due to anchorage slip, delta ES by L. Substitute the values, we will get again 42 Newton per mm square only. Total 42 plus 42, 84 Newton per mm square. Then percentage loss of pre-stress. Next problem, a post-tensioned cable of a beam 10 meter long is initially tensioned to a stress of 1000 Newton per mm square at one end. If the tendons are curved so that the slope is 1 in 24 at each end with an area of 600 mm square, calculate the loss of pre-stress due to friction with the following data. Coefficient of friction between duct and cable is 0.55. Friction coefficient for wave effect 0.0015 per meter. During anchoring, there is a slip of 3 mm at the jacking end. Calculate the final force in the cable and the percentage loss of pre-stress due to friction and slip. S is equal to 210 kilonewton per mm square. Again, here also you need to observe. First you need to find out loss due to friction. But along with friction, you can observe here, it is given there is a slip of 3 mm. So that means loss due to anchorage is also there. So you need to find out that also. You need to find out loss due to friction and loss due to anchorage slip. So first, loss due to friction, slope is directly given. You will get alpha, mu is given, k is given. X, it is a span of 10 meter is given. So x will be 10 meter. So total we will get friction loss of 60.83 Newton per mm square. Again, loss due to anchorage slip, delta ES by L. Substitute the values, we will get 63 Newton per mm square. Total loss 123.83. Then percentage loss. Then after all these losses, what is the final stress at the another end of the beam? From one end you are tensioning, what is the stress at another end? Initial stress, it is 1000 and minus total loss of pre-stress, you will get 876.17 Newton per mm square. So area is given, force, stress, load in stress in steel into area of steel. So that is 525.7 kilonewton. Since it is asked to calculate at the other end of the beam, so you need to consider stress at other end. Next problem. A pre-stressed concrete beam 300 mm wide and 600 mm deep is pre-stressed by the tendons of area 250 mm square located at a constant eccentricity of 100 mm and carrying an initial stress of 1050 Newton per mm square. The span of the beam is 10.5 meter. Calculate the percentage loss of pre-stress in the tendons if first condition the beam is pre-tensioned and second condition if beam is post-tensioned. Use the following data. Modular ratio is given, anchorage slip is given, friction coefficient for wave effect, ultimate creep strain for pre-tension and for post-tension both is given, shrinkage of concrete for pre-tension and for post-tension both it is given, relaxation of stress in steel is given, Young's modulus of steel it is given. So first, if you see the question, it is generally asked calculate the percentage of pre-stress and he is not mentioned which loss you need to find out. But if you observe the given data, all the data he is given, he has given cross section, he has given the span, he has given eccentricity, he is given modular ratio, anchorage slip, friction coefficient, wave coefficient, then ultimate creep strain, shrinkage of concrete, everything is given. So you need to calculate all the losses which are possible when the beam is pre-tensioned as well as when the beam is post-tensioned. So among all, the common factor you need to calculate is sigma C or FC. We can generally say stress in concrete. Stress in concrete you need to find out. So first, area, moment of inertia, stress in steel is given, area of steel is given, so we'll get pre-stressing force, eccentricity, since it is uniform eccentricity, right, there is no slope, this constant eccentricity, there is no slope at all, slope will be 0, everything is given. Stress in concrete at the level of steel, sigma C, P by A plus M by I into Y. M is P into eccentricity, since it is constant eccentricity throughout the span. Y is equal to E. Substitute the values, we will get sigma C as 1.94 Newton per mm square. Now we will consider a table. So first column is type of loss, formula, pre-tension member, post-tension member. Due to elastic shortening of concrete, this is first loss. For that we have a formula, modular ratio into stress in concrete at the level of steel, alpha E into sigma C. In case of pre-tension member, there is a loss due to elastic shortening of concrete. So we have calculated and we got 11.64. But in case of post-tension members, if you see the question, there is only one tendon with same eccentricity, whatever may be the eccentricity. As per the code, there will be no loss due to pre-stress, loss due to elastic shortening of concrete. In case of post-tension, if the cable is single, we have single cable, so there is no loss. If we have number of cables and the two, if we apply the tensile stress or pre-stressing force one after the other, then only we will have loss due to elastic shortening. Since we have only one cable, there is no loss due to elastic shortening, so it is no. Next, due to creep in concrete, see the data given, it is ultimate creep strain is given, so you need to go with ultimate creep strain method. So formula is ultimate creep strain into Young's modulus of steel into sigma C. Substitute the values for both. We have different ultimate creep strains for pre-tension as well as for post-tension. Substitute the respective values, we will get the answer. Next, loss due to shrinkage of concrete, again it is shrinkage strain into Young's modulus of steel. Again we have different shrinkage strain for pre-tension as well as post-tension. For pre-tension it is 300 into 10 power minus 6 and for post-tension it is 200 into 10 power minus 6. Substitute the values, we will get respective values. Then loss of pre-stress due to relaxation of stress in steel, it is given as 1%, that is percentage of initial pre-stressing force what you are applying. So in question it is given 2.5% of initial stress. So initially you are applying 10-15 Newton per mm square. So out of 10-15 Newton per mm square, 2.5% of stress is lost by loss of pre-stress due to relaxation of stress in steel. So it is 26.25. It is same for both case. Then loss due to friction, we have formula P naught into mu alpha plus Kx. In case of pre-tension there is no loss of friction, so 0. In post-tension here there is no slope since we are using straight cable, so alpha will be 0. Only you remain with K into X, 1050 into K into X. You will get some loss. Then loss of pre-stress due to anchorage slip, Es into delta by L. Again there is no loss in case of pre-tension, it will be only in case of post-tension. Substitute the values and get the answer. Total loss of pre-stress in pre-tension member, here you need to observe what are the losses we will get under pre-tension. Loss due to elastic shortening, then loss of creep, shrinkage and relaxation of stress in steel. Only 4 losses will come across with. So add the losses in third column, that is under pre-tension member. 11.64 plus 16.29 plus 63 plus 26.25, we will get 117.18 Newton per mm square. So if you take the percentage of those, we will get 11.16%. Similar way, if you consider for post-tension, add all the losses in last column, that is under post-tension member. Loss due to elastic shortening is 0, loss due to creep is 8.14, due to shrinkage it is 42, due to relaxation of stress it is 26.25, due to friction it is 16.53 and due to anchorage slip it is 30. If you add all, you will get 122.92 Newton per mm square, and if you take the percentage you will get 11.7%. So this is about today's problems. Thank you.